Okay, class, now we're going to do section 4.1 and 4.2, and if we can, we're going to do section 4.3. Okay, but let's see how far we get. In section 4.1, we are solving linear inequalities. Okay, in section 4.1, we're solving linear inequalities. Very good. Here is a linear inequality. So these are the inequality symbols. Greater than or equal to, less than or equal to. We call this inequality symbols. Okay? So I'm going to make up an equation with one of these symbols. Instead of, I should say, I'm going to make up a statement with one of these symbols, okay? When we have the equal sign, we call it an equation. When it has one of these symbols, we call it an inequality. So for example, 5/2 times x minus 3 is greater than or equal to 1/3 times x plus 4. This is an inequality. All right. One thing we must remember, and that is that whenever we divide or multiply an inequality by a negative, the symbol reverses. Yep, the inequality symbol gets switched. If it was greater than, it becomes less than. You see. Okay, so we're going to solve this inequality. And we're going to remember that whenever we have to divide or multiply by a negative, the inequality symbol is going to reverse. Okay. All right, so here we have this parentheses and parentheses. I am not going to worry about parentheses until I get rid of fractions. And to get rid of fractions, I take the 2 in the denominator and the 3 in the denominator, and we call it the least common denominator. In this case, just multiply them. 2 times 3 is 6. So the least common denominator is 6. Okay. I'm not going to worry about these parentheses. I'm going to multiply both sides by 6. Going to multiply this side by 6, and I'm going to multiply this side by 6. And when I say I multiply this side, I'm thinking, or I'm saying, I'm going to multiply every numerator by 6. So let me rewrite it. So 5/2 x minus 3 greater than or equal to 1/3 x plus 4. You see? And I'm going to multiply. I'm not going to worry about these parentheses, okay? I am not going to worry about parentheses until fractions are gone. That's the way to do it. So therefore, I'm going to multiply this by 6, this numerator, and this numerator by 6. Believe it or not, everything is going to get multiplied by 6. This fraction is going to get multiplied by 6. This x is going to get multiplied by 6. This 3 is going to get multiplied by 6. This 1/3 is going to get multiplied by 6. This x is going to get multiplied by 6. This 4 is going to get multiplied by 6. Everybody is going to get multiplied by 6, except that I'm not doing it right away. What I'm going to do first is I'm going to multiply this fraction by 6. And this fraction by 6. Okay. You see. All right. So 6 times 5 is 30. And 30 divided by 2 is 15. 15 times x minus 3 greater than or equal to 6 times 1 is 6. And 6 divided by 3 is what? 2 times x plus 4. There you go. Right there. Note, you see this 15? This 15 is 6 times 5 divided by 2. This 15 is 6 times 5 divided by 2. So this 15 has the 6 in it, the 5 in it, and the 2 in it. This 15 has 6 times 5 divided by 2. Okay. When you multiply this 15 into parentheses, when you multiply 15 times x, guess who's being multiplied by x? The 6 times the 5 divided by 2. Yep. When you multiply this 15 times x, they are all being multiplied times x, because that's where this 15 came from. When you multiply this 15 times 3, all of them are being multiplied. This is being multiplied by 6, by 5, divided by 2. So therefore, this x is also getting multiplied by 6. It's in there. This 3 is getting multiplied by 6. You see this x? This x is going to get multiplied by 6. 6 times 1 divided by 2. By 3, I'm sorry. And it's right there. This 6 times 1 divided by 3 is 2, right there. This 2 has a 6 times 1 divided by 3. Yes, it does. So let's distribute. Distribute, and they all go in there. 15x. Distribute, and they all go in there. You see? This 3 is getting multiplied by the 6 times the 5 divided by 2, except that you do not do it right away because you want to get rid of fractions first. So 15 times negative 3, negative 45. 2 times x. When you multiply 2 times x, you're really multiplying 6 times 1 divided by 3 times x. Yes, you are. That's how we got 2 in the first place. 2x plus what? 8. This 4 is also getting multiplied by 2, which in this case, 4 is also getting multiplied by 6 times 1 divided by 3. So everybody got multiplied by 6. Yes, this got multiplied by 6. This got multiplied by 6. This got multiplied by 6. Okay. The 6 is in there. Yep. Very good. Let's gather the variable terms on the same side. And just to make a point, I'm going to do this in 2 ways, okay? I'm going to bring this 2x to the left. So 15x minus 2x greater than or equal to, and I'm going to bring this 45 to the right. 8 plus 45. Okay. 15 minus 2x is what? 13. X greater than or equal to 45. 45 plus 8 is that 53? Divide both sides by, let me see, 39, 52, yep. Okay, so therefore this x is greater than or equal to 53 divided by 13, and that's your answer. Okay? So when you read this answer, we say x is greater than or equal to 53 over 13. And the 13 and the 53 can't be simplified anymore. All right, don't forget the answer. So here I brought the 2x to my left, the 45 to my right. Suppose I do it differently. Suppose I bring this 15x to the right. Okay? So let me erase this. Okay? Watch this. That's my answer, okay? Instead of bringing the 2x to my left, the negative 45 to my right, instead of that, let me bring the 15x to my right and the 8 to my left. The answer should be the same. Let me do it that way. Okay, so look at this. So greater than or equal to, we have a 2x there, and I'm gonna bring the 15x to my right, minus 15x. And this negative 45 is there, and I'm gonna bring the 8 to my left. So this is minus 8. Watch this. Negative 8 minus 45 is negative 53, greater than or equal to negative 13x. Okay, now like I said earlier, if we're gonna solve for x, if we're gonna have x by itself, we have to get rid of negative 13. We have to get rid of negative 13. How do you get rid of negative 13 there? You divide both sides by negative 13. And because we divide both sides by a negative, the symbol, the inequality symbol, is going to reverse. So divide this by a negative. Let me rewrite it. Divide by a negative. Divide by a negative. What happens to the symbol? It reverses. Whenever you divide or multiply by a negative in an inequality, the symbol reverses. The inequality symbol, that is. There you go. The 13 cancels. The negative 13 cancels. So we get x greater than or equal to, what's a negative divided by a negative? Positive. 53 over 13. Is that the same as this? The answer is yes. When you read the answer to an inequality, you always start with the variable. So if you read it from here, you say x, you start with the variable, is greater than or equal to 53 over 13. If you read this one, this answer, you start with the variable. You always start with the variable when you read the answers to an inequality. You say x is greater than or equal to, look, x is greater than or equal to 53 over 13. You said the same thing. What you said here was, you said this, x is greater than or equal to 53 over 13. So this is that. Okay. All right. So you see, as long as you remember, when you divide or when you multiply by a negative, the symbol reverses. Okay? Let me give you another example. All right? Here is another example. I'm going to give you another example, which is right here. So here are more examples. Let's try this one. Try this one for example. Try. Three x plus 1 divided by over 3 minus 4 minus 3x over or 5 is greater than or equal to negative 1/15. There you go. All right? So we see fractions again. Oh boy. Fractions all the time. Okay. Let's get rid of fractions. How do we get rid of fractions? Let's multiply both sides by the LCD, which is 15. When I say multiply both sides by the LCD, I really mean multiply every numerator by the LCD. Okay? So let me rewrite it. So 3x plus 1 over 3 minus 4 minus 3x over 5 is greater than or equal to negative 1 over 15. Okay? Multiply everything by 15. I'm gonna multiply this numerator by 15. When I say everything, I mean numerators, okay? Watch what's gonna happen. I better use parentheses because this is a binomial. Multiply this by 15. Multiply this by 15. And multiply this by 15. I am multiplying every numerator by 15. Basically, I'm multiplying both sides by 15. Like I said earlier, don't worry about parentheses. You see these parentheses? Don't worry about them until fractions are gone. The same thing as the prior example. So first, I'm gonna divide the 3 into a 15, which is what we wanted in the first place. Okay, you're saying, well, when is the 15 gonna get multiplied by 3x? It will, but not right away. It will after the fractions are gone. Okay. All right, so 3 into 15, what is it? 5 times 3x plus 1 minus 5 into 15, what is it? 3 times 4 minus 3x. Yep, greater than or equal to. The 15's cancel, we get minus 1. All right, very good. Now you're saying, well, when are you going to multiply the 15 times the 3x? I'm going to do it right now. Now the fractions are gone, I can do it now. It's easier. You see this 5? This 5 is 15 divided by 3. So this 5 has a 15, and this 5 has a 3 in the denominator, right? That's where it came from. This 5 is 15 divided by 3. So now, if the 5 gets multiplied inside, the 15 divided by 3 gets multiplied inside, because that's where this 5 came from. Okay. So let's multiply the 5 into the parentheses. No problem. 15x plus 5. When you multiply this 3 inside, you're really multiplying 15 divided by 5. Yes, you are. And it's minus 3, by the way. So minus was negative 3 times 4, negative 12. And what's negative 3 times a negative? Plus 9x, greater than or equal to negative 1. Combine like terms. Yes, we can. And 15x plus 9x is what? 24x. And 5 minus 12 is what? Minus 7. Greater than or equal to negative 1. Add 7 to both sides. So 24x is greater than or equal to, what's negative 1? Plus 7 is at 6. Divide both sides by 24 so that x is greater than or equal to, no, I'm dividing by a positive so the inequality symbol does not reverse. So 6 divided by 24, 6 divided by 24, and I know that 6 goes into itself once and 6 goes into 24 4 times. So therefore, the answer is x is greater than or equal to 1/4. By the way, I forgot to tell you that you can graph this answer. Yes, you can. Go to the number line. We're going to graph the answer. The number line, go to 1/4. Circle 1/4. And because it has equal, the 1/4 is shaded. And it also has greater than, so therefore this is greater than 1/4, and because it has equal, you better shade 1/4. That's the graph to that. In addition, you can have this answer in interval notation. Note, from 1/4 all the way up to where? Infinity. So we say from 1/4 all the way up to infinity. Infinity is always written on the right. Negative infinity is always written on the left in an interval answer. So this is an interval answer. So therefore, 1/4 is included. Look, it's shaded, so that's bracket. If it's not shaded, it's parentheses. Infinity is parentheses, you'll never get to infinity. So you can also write it that way. What's another way you can write it? So this is interval notation. This is the graph. And one more, set notation. Set notation is x such that, and they just write this. X is greater than or equal to 1/4. And then we use set notation. And there you go. Beautiful. So therefore, we could have done this to the prior problem, but I forgot to do it. Okay. Graph, interval notation, set notation. Okay, very good. Excellent. Okay. So now let's go ahead and do compound inequalities. Okay? Okay, section 4.2 is compound inequalities. The first thing that we need to explain is the connective word and. And then we'll explain the connective word or. Connective words and or. The word and refers to the intersection. The connective word and is the intersection. The connective word or is the union. And is the intersection between two sets. Or is the union of two sets. So, by the way, or for or we use you is equivalent. How can I say this? The symbol for or is you. There you go. The symbol for or is you. For the union, the symbol for and is upside down U, to just do this, for the intersection. Okay? So when you see this, that means or. When you see this, that means and. All right. So I'm going to make up two sets. And first, I'm going to take the union. Basically, I'm just going to unite them together, okay? That's what I'm going to do. If there are repeated numbers, then you list them once in the union. For example, here is a set. 1, 2, 3, 4, and 5. And this is set A. Here is set B. 4, 5, 6, 7, and 8. This is set B. If you take the union, all you need to do is unite them. If any element or values are repeated in both sets, in the union, they get listed once. For example, I'm going to unite those two, but you see the 4 is in both sets. In the union, just listed one time. The 4 and the 5. So let's unite. Let's unite. When you put them together, the 4 and the 5 it's repeated in both sets, no problem. The union will only have 4 and 5 one time. So here's the union. The answer, A union B, is gonna be, just unite. 1, 2, 3, 4 is in both, but it only gets listed one time. 5 is in both, but it only gets listed one time. 6 is in B, 7 is in B, 8 is in B. So here is the union. That's the answer right there. How about A, the same A, intersect B. What's this answer? Well, now we want all those values that are in both set A and B. It's gotta be in both. Is 1 in both? No. Is 2 in both? No. Is 3 in both? No. 3 is not over there. Is 4 in both? Yes. So 4 is in the intersection. Is 5 in both? Yes, 5 is in both. So 5 is in the intersection. Is 6 in both? No, 6 is not here. 7, not here. 8, not here. So that is the intersection right here. So for the intersection, we want what is in both sets. For the union, we just unite any numbers or elements that are listed in both sets get listed one time, as in 4 and 5. Okay, so there we go, right there. Okay, so now I need more room, right? Because now, what I'm gonna do now is the following. The set A is x greater than or equal to 6. That's set A. Set B, set B is x less than 10. Okay? Suppose I want A union B. Okay? Well, all you have to do is unite both sets. That's all you have to do. The best way to do this problem is the following. Watch this. Write A here and graph A. What's the graph of A? Here is 6, circle 6, say 6, look, I'm just doing this, greater than. So this is x greater than or equal to 6. I just did this. Right below it, write B. Now I'm gonna graph B. B. So B is, it says less than 10. So here, don't forget, this 6 is to the left and 10 is to the right. 10, circle 10. Do not say 10, look, do not say 10, and it's everything to the left. So that's B. That's B. You have not taken the union yet. You haven't. To take the union, just put those two graphs together. If you put these two graphs together, collapse one into the other, what's the answer? So right below, if you write A union B, if you want to graph that, it's a single graph, put together. Everything gets shaded, right? Everything gets shaded because look, this 6 is shaded. It's also shaded here. everything is shaded around 6 all the way to the negative infinity. This 10 is not shaded, but this one is going to shade it because you put it together. The 6 get listed one time, okay? So therefore, here is the graph. Right there. Everything is shaded, guys. Everything is shaded. That's the answer. Everything, the entire number line is shaded, guys. Entire number line is shaded. So therefore, in interval notation, the answer is from negative infinity up to positive infinity. That's the answer. If you want to give, you can also say this, the answer is all real numbers, right there. That's the answer. Okay. So the answer to this is R. Answer is R. That R means all real numbers. Okay, that's this one. How about A intersect B? Okay, we're going to use the same graph right up above, but now let's change this. Now we want what both sets have in common. What do they have in common? Do they have 5 in common? No, 5 is not in common because 5 is shaded here, but look, 5 is not shaded there. Do they have 5.9 in common? No, 5.9 is not in common to both because 5.9, although it is shaded here, it is not shaded there. 5.9 is not common to both. How about 6? Oh yeah. 6 is shaded here. Look, it's also shaded there. So therefore 6 is in the union. I'm sorry, in the intersection. It's also the union, but that's not the question. The question is the intersection, right? A intersect B. And we just realized that 6 is in there. Let me graph it, okay? Only what they have in common. So therefore, 6, yes, 6. Circle, and it's both common to both. How about 7? Yes. How about 6.1? Yes. How about 6.2? Yes. How about 6.3? Yes. How about 9? Yes. How about 9.9? Yes, it's coming to both. 9.9 is here, shaded here, also shaded there. How about 10? Is 10 common to both? The answer is no. This is open. So therefore, 10 is open. Everything in between, including 6. That is the intersection. All right. Excelente. Okay. How about interval notation for the intersection? Well, the interval notation is going to be what? 6, including, look, so you better use parentheses, brackets. All the way up to 10. Is 10 included? No. Parentheses. Right there. If you want to give the answer in set notation, you say the answer is x such that x is less than 10, greater than or equal to 6. Excelente. So now let's step it up. You see how I gave these examples? Consider the next example. consider the following. Okay? So, let me erase this example and let me make it a little bit more complicated. Just a little bit, okay? How about if we do this? A is the following. A is 2x is greater than or equal to -6. Yeah. B is 6 minus 4x is less than, I'm gonna say, less than 2. There you go. Okay. All right, very good. The book doesn't write it like this, guys. Here's what the book does. It's suppose I want to give you the union. Find A union B. The book does not necessarily do it like this. Here's what the book does. The book is going to ask you this question like this. 2x greater than or equal to -6 union 6 minus 4x less than 2. So those two are the same. Okay. Well, the first thing we need to do is we need to simplify set A. This is set A. How do you simplify set A? Well, to simplify set A is divide both sides by 2. Okay. Divide this by 2 and we get x. Divide this by 2 and we get -3. Okay, and we simplified set A already. Simplify B. No problem. Subtract 6 from both sides. -4x less than, what is 2 minus 6? -4. Not done. So here x is greater than or equal to -3, or I'm going to divide both sides by -4. What happens when you divide by a negative? The symbol reverses. So divide this by negative, you get x. Divide this by -4, you get 1. And the symbol is going to reverse. So there you go. Believe it or not, this is A in simplest form, and this is B in simplest form. Right there. Now I have to get the union. What we did earlier was, let's take A and let's graph A. This is A. A is x is greater than or equal to -3. Let's just graph it. Here is -3. Circle -3 is everything to the right. And also shade -3 right there. This is set A right there. This is A. Yes, it is. How about B? There's B. X is greater than 1. Okay, no problem. This -3, 1 is to the right, so let me just write it here. This is 1, circle 1, do not shade 1, is everything to the right. And this is set B. Now let's take the union. Let's take this, let's do this. We're taking the union. To take the union, just put the graphs together. When you put the graphs together, A union B, and what do you get? Just put the graph together, guys. Okay, you're gonna get this one from -3, circle, shade, all the way to the right. That's the answer. So the answer to this is gonna be from -3 all the way up to infinity, including -3, excluding infinity. And there's the graph. If you want it in set notation, the answer is x such that x is greater than or equal to -3, and this is the set notation right here. Okay, beautiful. Let's do one from the book. I think we are ready. Oh, here's a good one. Here is an inequality with 3 sides. No problem. No problem at all. Okay? No problem at all. So I'm going to have to erase this now. This has to go. Okay? Sometimes you'll get questions like this. Look. Yeah. You'll get solve for x. -5 less than or equal to 3x. -8 less than or equal to 7. Okay, no problem. You see the middle side right there in the middle? That's where the x is. You need to simplify this. You need to isolate x by itself. To isolate x, you better add 8 to this side. But if you add 8 to this side, you better add 8 to the right-hand side, and you better add 8 to the left-hand side. Yeah? You gotta add it to all 3 sides. So if you add 8 to this side, you get 3x. If you add 8 to this side, you get 15. If you add 8 to this side, what's 8 minus 5? You get 3. Divide everything by what? Divide everything by 3. Divide this by 3 and you get 1. Divide this by 3 and you get x. Divide this by 3 and you get what? 5. There's your answer. You want the internal notation? Sure. From 1 all the way up to what? Up to 5, including, we use bracket because it has equal, including, we use bracket. Right there. That's the internal notation. Do you want to graph it? Sure, you can graph it. If you want to graph it, go to 1 and 5, circle 1 and shade it because it has equal, circle 5, shade it because it has equal, and everything in between. That's the graph to that. Do you want the internal notation? Sure. The set notation. Do you want the set notation? Sure. Here's the set notation. X such that x less than or equal to 5, greater than or equal to 1. And here we go. And here we go. Right there. Okay. is the way we do section 4.2. All right? This is section 4.2. Section 4.2. Okay.